I'm brighter now. That's good. Perfect. So let me stand in front of the screen. Anyway, a Z standard compression. So Facebook finally contributing something. Well, they've contributed many things, but to the good things of digital sovereignty and privacy protection and so on. So anyway, thank you to them, really. So a bit of background. How Collabora Online works is that we have all sorts of beautiful tiles in the background. You can see them. This is a debug mode with blue around them. So what looks like a seamless document and behaves like a seamless document and pans and moves and zooms in your browser is really a whole selection of tiles. And they're 256 pixels square because this is good for mobile GPUs. So we heard from the Firefox people long ago, and we believed them, and so we've stuck with that. So that's good, but they need to be got from the server side where they're drawn, which means that everyone has the same view, independent of fonts or whatever you have installed. You can install your fonts in your Nextcloud or whatever, stick them on the server, and then it all renders the same everywhere. So that's great. But we need to get them from the server to us, and there's quite a lot of pixels there. So this is a benchmark that we do for just mashing the keyboard in the suite, and we can profile that nicely and see where the cost is. And the interesting thing here is that the rendering is really very significant as a chunk of it, and it's a little bit unexpected that it's as significant as it is. But anyway, we optimize in pieces, bit by bit. So this is a modern one. So we used to have this piece used to be very much bigger, but I'll talk about that later in my deltas talk. But anyway, we do basically two bits of compression. We compress raw tiles. So when we have a first tile, like a keyframe, and we also compress deltas, which is like a small change between tiles. Now, I saw this graph and I thought, ooh, when you look at this graph, Amdahl is not kind to people who optimize this little piece here, but he's kind to people who optimize this piece. So that's good. So maybe it's a quarter of the time. And it turns out that Facebook have made a better zlib, one that works nicely with modern CPUs and, is just much more elegant than the very old deflate. Now, of course, there are lots of better ways to compress data. You can use an arithmetic AI compression scheme that compresses the whole world down to 1 bit until you change something, over there, until you don't move, But these are kind of expensive, and so you can do lots of work to get size off. I don't know if anyone's seen the Burroughs-Wheeler transform, but if you haven't looked at the Wikipedia page, you should look at it. It's got a great example, and you just can't believe how it works, but it does work. But it's also very slow. And what we want to do is we want to reduce CPU load on the server and get our data out as quick as possible. So there's a trade-off there between size and speed. But however you look at, so this is speed and this is the compression ratio. However you look at it, this is not a good place to be over here. It would be much better to be over here. So going from the weak, we optimize for speed with zlib. And yeah, it's 5 times faster in the first iteration. So that's pretty good. If you remember this again, if we can make that this big, that really helps. So that's cool. I got a pull request on GitHub. It even works. It compresses deltas as well. There's actually some optimization to apply keyframes and deltas more quickly. Maybe I'll talk about that later. Android and iOS don't have Z standard on them by default, which is kind of annoying. They're behind the times, these trendy mobile devices for 1,800 euros, and it still doesn't have Z standard compression. It's like, what? What are you thinking about? So anyway, we need to encourage someone at the back in a Kavak t-shirt, and to help me, yeah, I know, to help me get the iOS and perhaps Android pieces in. I didn't do the JavaScript side, so thanks to Henry, if he's watching. Awesome work there. All of that wonderful Node, no. Gradle, no. Anyway, there's a cargo culting tool that we use for bringing JavaScript dependencies in. And yeah, he did that bit. That's cool. What next? Well, turns out that it's already pretty awesomely fast. But if you put a dictionary in there that looks like the kind of things you compress, which tend to be white documents with not much in them, black text, then you can get the compression speed up again by some significant factor. And for small files, you can get the compression ratio right up. Obviously, if you had exactly the file you're about to compress, you could, it would be absolutely tiny. So we should probably build a reasonably sized dictionary, download that as a blob once to all the clients, and then compress against that in the JavaScript. So that would save more bandwidth. And we give numbers of like 75% performance bandwidth reduction. It really depends. If you insist on doing massive layout things continually that we can't use deltas for, and then you'll compress a lot of tiles. And well, I don't know. Oh, I'm talking about deltas again. I'm confused between my two talks. Never mind. So other things that we should compress. So tiles are currently shared between all users. So every user has the same view. So we compress once and serve to 30 people in a meeting, something like that. So that's kind of cool. And the same for deltas. They're also, on top of those. But there are some quite big things, and I'm looking at you, JS Dialogues. Where are you? Yeah. And so we should probably, if we're going to send the same things to many people, we should compress these. It seems quick. And if we can send it to lots of people, we'll save more bandwidth there as well. And I should have got the diagram. After a lot of the delta work, the images start to be approaching half of the bandwidth we use outcoming. So, there's more low-hanging fruit that we could apply this to elsewhere. And that's pretty much my talk, I think. Thank you.